circuits which is connected with a ideal voltage source with the ideal capacitor and a ideal current source connected with the ideal inductor. So first let's discuss about the ideal voltage source connected with the ideal capacitor. Let's take this is a switch which is also ideal switch, so there is no on resistance to the switch. This switch is closed at t is equal to 0. That means this capacitor is seeing a V voltage at t is equal to 0. Okay, but this ideal voltage source is having the V volt. Let's assume this is a V volt from minus infinity to plus infinity. But capacitor is seeing this kind of voltage. That means this is a step voltage which is seeing at t is equal to 0. Because at t is equal to 0, the capacitor is seeing this high frequency signal. The capacitor will act as a short circuit at frequency is equal to infinity. So as this capacitor is also ideal, there is no resistance in series with the voltage source. So if I calculate the current flowing through the voltage source or capacitor, A is equal to V by R, V is equal to V volt and resistor is equal to 0. The current flowing through the capacitor and ideal voltage source is infinity ampere. Because the current flowing through the capacitor is infinite ampere, the capacitor will suddenly charge to V volt at t is equal to 0 plus simply. Let's take one example here. Let's take I have programmed this voltage ideal voltage source to 10 volt and the capacitor I have connected 1 farad capacitor. Okay, if I calculate the current flowing through the capacitor at t is equal to 0, 10 volt divided by 0 resistance, because this is the ideal voltage source and ideal capacitor, infinite ampere will flow. So that voltage, because infinite amount of current is flowing through the capacitor, voltage will suddenly build to 10 volt across the capacitor. This is the this is purely because of the behavior of the ideal voltage source. Okay, let's discuss about the behavior of the ideal current source connected across the ideal inductor. Here I am not using any switch here. Instead of that, I am using the step current source. A current source is having 0 ampere till t is equal to 0. At t is equal to 0, this is being transitioned to, let's assume, a amps. Okay, so because there is a change in the current at t is equal to 0, so you know that xl is equal to 2 pi fl, as this is a L is a fixed and f is a infinite frequency, so xl will be infinite. So that means inductor is acting as an open circuit. But this is the ideal voltage source, it will not allow to change the current, because that means if the inductor is infinity, that means inductor is open, that means that these terminals are open here. But here what we have, ideal current source. What is the property of ideal current source? The current source is having, the ideal current source will definitely force programmed current. That means here we are programming it to a amps by varying voltage across the ideal current source from minus infinity to plus infinity, so that at t is equal to 0, ideal current source voltage will shoot from 0 volt to plus infinity volts, because here the current should be flow in positive direction. That's why it is shooting it to plus infinity volts at that time. Because it is shooting it to plus infinity volts across the inductor, so that inductor will allow a amps of amount of current through it. So this is the property of the, this is how it behaves when we connect a inductor across the ideal current source.